Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of lateral surfaces of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a hexagonal pyramid with base edge 30 mm and axis height 80 mm. Now this hexagonal pyramid is resting on its base on the horizontal plane with one of the base edges parallel to the vertical plane. So here we can check one of the base edges of this hexagonal pyramid happens to be parallel to the vertical plane over here. Now this hexagonal pyramid has been cut by two mutually perpendicular cutting planes over here. So we can check this is cutting plane number 1 and this is the second cutting plane. So the two mutually perpendicular cutting planes, they are intersecting with this hexagonal pyramid. So this portion of the solid, it will be removed and we are left with the remaining portion of the solid over here. And now we are required to obtain the development of the lateral surface of the remaining portion of the truncated solid over here. Let us now proceed with evaluation of top view projections and the front view projections of this hexagonal pyramid. Now as the observer is going to view this hexagonal pyramid from the top, so we are going to obtain the hexagonal construction projections obtained onto the horizontal plane over here in the top view projection. Now we can check, we have obtained the hexagonal projections onto the horizontal plane with an edge length of 30 mm. Now the 6 points of the base we have drawn A, B, C, D, E, F, and here we can check that this base edge EF, it happens to be parallel to the vertical plane. So now we need to obtain the axis of this hexagonal pyramid. So we need to join the three diagonals AD, BE and CF corresponding to the base of this hexagonal pyramid. Wherever these three diagonals of this hexagon, they are going to intersect with each other, we obtain the axis points O and O1. So point O corresponds to the apex of the hexagonal pyramid, while point O1 happens to lie onto the base of the hexagonal pyramid corresponding to the axis of the pyramid. Now having obtained the top view projections corresponding to this hexagonal pyramid, now let us obtain the front view projections corresponding to this hexagonal pyramid. So point A of the base has been projected as point A dash into the front view projections onto the XY reference line. Points B and F, they have overlapped with each other and they are projected as points B dash and F dash onto the XY reference line in the elevation projection view. Similarly, points C and D, again they have overlapped in the elevation projection view and they are represented as points C dash and E dash onto the XY reference line. And the point D of the base, it is projected as point D dash onto the XY reference line in the front view projections over here. So the axis points we had obtained earlier into the top view projection view. So from points O and O1, we have drawn the axis line and extended this axis into the elevation projection view. So we know that axis height, it is equal to 80 mm. The moment we mark the axis height, so we'll be able to locate the apex point corresponding to this hexagonal pyramid over here as point O dash. So once we obtained O dash point corresponding to the apex and O1 dash point corresponding to the axis point of the base over here, now we can join all the slant edges of this hexagonal pyramid. So we have joined the slant edges in the front view projections as O dash A dash, O dash B dash, O dash C dash, O dash D dash, O dash E dash and O dash F dash over here. Now one thing we need to observe over here, that the slant edge OF happens to lie on the rear side of the solid. So it will not be visible to the observer, but the slant edge OF is superimposed by the slant edge OB, which is available with us on the front side of the solid. So therefore, the hidden line or the dotted line projections corresponding to the slant edge O dash F dash will be superimposed by the object line projections corresponding to the slant edge O dash B dash into the front view projections over here. Similarly, this slant edge OE, it is available with us on the rear side of the solid and it is not visible to the observer while the observer is going to look at the solid from this orientation. So now this slant edge OE is also superimposed by this slant edge OC over here, which is available with us on the front side of the solid over here. So we are going to obtain the hidden line projections corresponding to the slant edge O dash E dash over here, but these hidden line projections or the dotted line projections corresponding to O dash E dash will be superimposed by the object line projections corresponding to the slant edge O dash E dash in the front view projections over here. So that is why once again we are not able to observe the hidden line projections corresponding to the slant edge O dash E dash into the front view projections over here. So now we have been able to obtain the front view projections and the top view projections corresponding to this hexagonal pyramid. So now we know that there are two cutting planes which are mutually perpendicular to each other. So the first cutting plane, it passes through the axis of this pyramid and it extends up to the height of 30 millimeter from the base, and then it changes the direction, and now the second cutting plane, which is parallel to the horizontal plane, it is going to cut this particular hexagonal pyramid. This portion of the hexagonal pyramid has been removed by the cutting action of these two mutually perpendicular cutting planes with the hexagonal pyramid over here. Now let us evaluate different points of intersection in the front view projections corresponding to these two cutting planes intersecting with the hexagonal pyramid. So we know that the cutting plane, that is the horizontal cutting plane, it has intersected with the slant edges O dash C dash and O dash E dash at the points 13 dash and 15 dash respectively. Point 13 dash is the point of intersection corresponding to the intersection of the horizontal cutting plane with the slant edge O dash C dash over here, whereas point 15 dash, it is the point of intersection of the horizontal cutting plane with the slant generator O dash E dash over here. So the 2 points of intersection we have obtained. Next we have got the point of intersection which is point 14 dash over here. So point 14 dash happens to lie onto the slant edge O dash D dash over here. So the third point of intersection we have obtained as point 14 dash. Now the next 2 points of intersection, they are lying onto these two slant generators which are not available with us directly. We can check it out over here. There are two slant generators. One slant generator happens to be O11. Another slant generator happens to be O17. So this slant artificial generator is obtained onto this triangular face. So point 11 happens to be the midpoint of BC. Point 17 happens to be the midpoint of the base edge EF over here. So once we join this slant artificial additional generator which is available with us corresponding to point 11. So where does point 11 and 17 lie? Point 11 and 17, they are available onto the base of this hexagonal pyramid by virtue of intersection of the vertical cutting plane with respect to the hexagonal pyramid. So we have observed that this vertical cutting plane, it has intersected with the axis of the hexagonal pyramid in such a way that this height of this cutting plane happens to be 30 millimeter. So we will be evaluating these points 12 dash and 16 dash later on. first of all, we have to evaluate the points 11 dash and 17 dash over here. So now we see that onto this triangular face, we can check. In the top view, it will be visible appropriately. So onto this triangular face, which happens to be inclined with respect to the horizontal plane, we can check OBC. So onto this horizontal plane, we will see that the point number 11 has been obtained by virtue of intersection of this vertical cutting plane with the base edge BC at point number 11 over here. So this point number 11 we can check, we have appropriately obtained onto the base edge BC over here. Similarly, onto this rear triangular face, which one is this rear triangular face? This happens to be O, E and F. So the apparent shape projections, they are visible to us in the top view projections over here. Now onto this triangular face, this cutting plane is going to intersect the base of this hexagonal pyramid at this point, and this point happens to be point number 17 over here. This point is point number 17 at the midpoint of the base edge, which is lying on the rear side as edge EF over here. So 2 points of intersection, 11 and 17 in the top view projections and 11 dash and 17 dash in the front view projections, corresponding to the intersection of this vertical cutting plane with the base of this hexagonal pyramid, they have been evaluated. Now, once we join these two additional slant generators over here, which are available with us by virtue of joining of point O with midpoint of BC, that is O11, and joining of point O with midpoint of the edge EF over here. So again, these two surfaces, since they are inclined ones, so this edge, it will also be inclined one. O11 will be inclined and O17 will also be inclined. Now onto these two additional generators, we can say, so these are two artificial generator, O11 and O17. Now at a height of 30 millimeter from the base, 2 points we have been able to obtain as points 12 dash and 16 dash over here. So these 2 points, they will be common with horizontal generator and the vertical generator as well. So we can check, if we measure distance of 30 millimeter from point 11 over here, that is the vertical distance. So this point number 12 will be located over here. Similarly, onto this slant generator, that is O70, again if we measure 30 millimeter from axis, so we'll obtain the point 16 onto O17. Point 12 has been obtained onto this artificial generator O11 over here. So this way, 2 points of intersection 12 dash and 16 dash will be common to both the cutting planes over here. Now with this information, let us proceed to evaluate the development of the lateral surface of this hexagonal pyramid. Now we can check the top view of the slant edges OA and OD. So OA top view projection apparent length and OD top view projection apparent length. So both of these apparent lengths OA and OD, they happen to be parallel to the vertical plane. So in the front view projections, O dash A dash projection in the elevation and O dash D dash projection in the elevation, they will be representing true length of the slant edge corresponding to this hexagonal pyramid over here. So we have evaluated the true length of the slant edge of this hexagonal pyramid as O dash A dash and O dash D dash over here. So now we have discussed that this portion of the solid has been cut. So this is the remainder portion of the solid. Now we are required to obtain the development of the lateral surface of the remaining portion of the truncated pyramid over here. But before that, we need to obtain the lateral surface development of the regular hexagonal pyramid, which is available with us. So now the true length of the slant edge is available as O dash A dash and O dash D dash over here. Now with this radius equal to O dash A dash or O dash D dash, So with O as center, with radius OA equal to O dash A dash and O dash D dash over here, we are going to draw an arc corresponding to the true length of the slant edge over here. Now, what we are going to do, we know the edge length corresponding to the base equal to 30 millimeter. So corresponding to 30 millimeter edge length, 6 arcs representing different edges of the base we are going to obtain. So first of all, the corner points we are going to obtain over here. So at a radius of 30 millimeter from point A, the corner point B will be obtained. Another arc of 30 millimeter radius we are going to draw. So similarly, arcs D, E, F and A, they will be drawn having radius equal to 30 millimeter alongside this curve which we have drawn corresponding to the true length of the slant edge over here. So now we can join all the slant edges over here, and once we join all the slant edges, now we can join the edges of the base over here into the developed surface view. Now let us work out the true orientation or the location of these different points of intersection into the developed surface view over here. Now we can see over here that into this front view projections, since OA and OD, they were represented as apparent lengths parallel to the vertical plane. So in the front view, O dash A dash and O dash D dash, they have been projected as true length of the slant edges over here. So this distance of point 14 dash from point O dash, this will be represented by true length of the radius of point 14, because it is lying onto the true length over here. Whereas these 4 points 12, 13, 15 and 16. So these 4 points, they are obtained onto the apparent length of the generators over here. Points 13 dash and 15 dash, they are lying on the generator O dash C dash and O dash E dash. Whereas points 12 dash and 16 dash, they happen to lie onto new artificial generators which are O dash 11 dash and O dash 17 dash. These are two slant generators which have been obtained corresponding to the midpoint of the points of the base over here. So let us obtain these two base points into the developed surface view over here. So point 11 happens to lie between points B and C as its midpoint. So midpoint of B and C we have obtained in the developed surface view. So point 11 has been identified. Similarly, point 17 happens to lie on the midpoint of the edge EF. So on the edge EF in the developed surface view we have obtained the midpoint. So the point 17 has been generated over here. So now we can join O11 and we can join O17. So these are two additional slant generators corresponding to the midpoints of the base points 11 and 17 over here. And onto these two generators, two more points 12 and 16, they need to be obtained over here. But these 2 points 12 and 16, they are obtained onto the apparent lengths over here. So now corresponding to these 4 points 12, 13, 15 and 16, we have to project these points into the true length over here. That is, we are not going to take this radius O dash 12 dash, O dash 16 dash, O dash 13 dash or O dash 15 dash over here. What we have done over here, from these 4 points 12 dash, 13 dash, 15 dash and 16 dash, a horizontal projector line has been drawn onto the true length of the slant edge, which happens to be O dash D dash over here. So now we can check, once we project these 4 points onto the true length, they are going to coincide over here with the point 14 dash over here. So the names of these 4 points into the true length projection will be 12 1 dash, 13 1 dash, 15 1 dash and 16 1 dash. So at this point we observe that all of these 5 points, that is 12 1 dash, 13 1 dash, 14 dash, 15 1 dash and 16 1 dash, they have all coincided with each other. That is, all these 5 points, they will be available at the same radius, which will be equal to O dash 14 dash over here. So now we can draw another curve over here, starting from point O. Once we measure this distance, O dash 14 dash, so corresponding to the same radius, we have drawn an arc over here. Now, onto this artificial slant generator, O11, point 12.1 has been obtained, and onto this new artificial slant generator corresponding to the midpoint, point 17, lying on the rear side of the edge EF over here at the midpoint. So, point 16.1 will be obtained over here. So, the 2 points which are common to both the vertical and the horizontal cutting plane, they have been obtained over here. Now the next point of intersection, it happens to be 13 dash and 15 dash, and it has to be obtained onto the generators O dash C dash and O dash E dash over here. But because this is an apparent length of the generator, so this distance is the apparent length O dash 13 dash and O dash 15 dash. So we are not going to mark these two distances, rather we will be marking the distance O dash 13.1 dash and O dash 15.1 dash. That is distance of these 2 points of intersection onto the projection line we need to obtain over here. So this radius we are going to draw. So onto the same arc, once again, onto slant generator OC, point 13.1 will be located. Onto slant generator OE, point 15.1 will be located over here. And finally, we have observed that this horizontal cutting plane, it has intersected with the slant edge O dash D dash at the point 14 dash over here. So onto this slant generator O dash D dash, which is a true length, we measure the distance O dash 14 dash over here. So this point will be plotted over here. So there is no suffix over here because it is already lying onto the true length of the slant edge over here. So now we have obtained all the points of intersection into the developed surface view. So let us join all of these points of intersection, and now we will observe that this happens to be the development of the lateral surface of the remaining portion of the truncated pyramid. So here we can check this slant generator OC was cut at the point 13. So this is O13 which is left behind. So O13.1 we have drawn over here. Similarly, O dash D dash was cut at point 14 dash. So this is again the left behind slant generator. And finally here we have got O dash E dash slant generator which has been cut at the point 15 dash. So correspondingly, this is the left behind portion or the remaining part of the slant generator OE which is left behind. Whereas the generators OA, OB, OF, so they have not been intersected by the cutting plane. So they have been represented as such into the developed surface area over here. So with this, we have discussed about obtaining the front view projections of the section solid, the top view projections of the solid, and the development of the lateral surface of the truncated hexagonal pyramid over here. So this is all for today. So I hope that through this discussion, you would have understood the procedure to obtain the front view, top view orthographic projections, and the procedure to obtain the development of the lateral surface of the truncated pyramid over here. So we are going to continue with further discussion regarding few more illustrative cases of development of lateral surfaces of the solids in the coming lectures as well. So thank you very much. Thanks a lot.